And good morning, super friends! Because Peter said, hello, squirrels, I had to quickly grab them. Oh no, falling! They don't balance very well like that. Okay. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Kind of slightly on that topic, at the barbecue, was it last week? It feels like it was a month ago. At the barbecue, at some point I was standing out the front talking to someone about the factories down the street here and how, the factory that I'm currently in now was built in the 80s, which is kind of around the era that this area was built out, this industrial area. And I talked about how prior to that time, this whole area would have just been open land and fields and greenery. And yes, I have this strange thing sometimes when I go to different places. I think it's primarily places where there is a little bit of geographic interest, like it's built up, but there are slopes and things. And there's a place not far from here called Burnt Bridge. I had this thought driving through there. So it's a little bit of a culvert. But there's a supermarket there, a big road, all of those sorts of things. And the fact that it's called Burnt Bridge makes me think that obviously at some time in the past there has been a bridge there over a creek which no longer exists. It's probably now an underground stormwater drain. And the bridge must have burnt. So it's been called Burnt Bridge ever since. But at some point that would have been a nice little open area of countryside with lots of trees and grass, and as it had been for, I have no idea how long, tens of thousands of years. And then we've come along and put a main road through it and built a supermarket and all of the other things that go along with it, and now you can't even see the original land. The land is under everything. Sad thoughts in some ways. Amanda, thank you for the pizza fund. Maybe I will go and get pizza for lunch. Gerald said you better watch out, you better not cry, you better not pout. I'm telling you why. Henrik Claus is coming to town. Yes, because today we have the mystery package from Henrik. So good morning to Gerald, Peter, outside the box, otherwise known as Chip, or known to me as Chip at least. Stephen and Keith is here. Who else? Dave Paul Jones, some call it fun. Johnny Bergdahl is here, family plans. Johan, Justin C, Simon, Dodgy is here, bus driver now 319. I don't think I've seen that name in the chat before. Mark Wolf is here. Good morning, Mark. I haven't seen you for ages. So long. Imogen is here, and David, I think. Oh, Mitchell. Did I say hi to Mitchell earlier? Cassio, the Lane. Oh, it's good to see you all on a Sunday morning. Philip is here. Awesome. And now you might be able to hear that my voice is a little bit not so good. Oh, Paul is here. Nath Dev AU. I've got a bit of a sinus infection, which hopefully won't cause any particular problems for this stream. Oh, Kim S is here. Oh, Henrik! Okay, so Henrik says, please read my comments. I will do my best to follow your comments, Henrik. So I'm going to be definitely paying attention because I'm going to be asking you questions, I'm sure, as we go as well. I just may miss them because the chat streams by so fast. So if I do happen to miss any of your comments, or if other people notice me missing Henrik's comments, please speak up. Mitchell, yeah, that's not going to be a problem. Yeah, so by last night, I've had the symptoms that make me think that maybe I've got the nasty thing. So I did a test this morning, and I tested negative for COVID. So it's just a sinus infection, I think. Just a regular old thing. Yes. Okay, so Peter said, Henrik said you should have 2 packages, open the smaller one first. Yes, I do have 2 packages. Now, just before I get to those, can open it correctly. Okay, before I get into opening the packages, because that is going to take up who knows how long of the live stream, probably the whole thing, I just want to point out something that Peter messaged me about this morning. Something very interesting, which is this. Espressif launches a kit to turn its ESP32 modules into certified thread border routers for Matter. Now that is interesting. In a few ways, it's probably the most significant thing is that it means that you can build a Matter router on just a very small dev board with a microcontroller on it, without needing a full operating system stack like a Linux box or something. So yeah, it pushes the scale of that sort of thing down to a point where it's reasonably cheap, and but what also interests me is that it provides a good example, a hardware reference and a software reference for a microcontroller participating in a thread network. And so that could be useful if you are interested in building your own devices that connect to a Matter device that connects to a smart home network. So I am extremely tempted to just hit buy now on one of these and start playing around with it. There's a little diagram of the stack there. And what is this one? The ThreadBR development board, designed to be paired with an ESP32H2 daughter board above. Okay, so that's an ESP32H2 daughter board. That's got a WISNet chip on it. Why is there a WISNet chip on there? Probably for the Ethernet. Looks like an RJ45 socket. But why haven't they done that in the ESP32? I don't know. Maybe it... anyway, I'm not going to get into all the details of this. Just pointing out that this is interesting. We're at the point now where, yeah, so this is what I was hoping would happen. The danger with something like a new communications methodology, and I use that word carefully because it's communications between devices involve many layers, and at each of the layers they can be made proprietary. And so one of the dangers when a number of big companies get together and decide on a new standard for how devices should communicate is that they put some kind of secret sauce or restrictions on how you can participate in that network, because all companies want a walled garden, they want to control everything. And the fact that you can build a thread router running on ESP32 like this, running, and where is it? So it is developed using the IDF, I think it said just down in here. So yeah, built on the ESP IDF and the open source open thread stack. So that gives me hope that it'll be possible to build open source devices that participate in a thread network in a reasonably straightforward way. Okay, so oh, Mark said, been hacking on Thread. It is super complex and mostly open. There is still a certification process and a bunch of information behind membership. Yeah, so that is that doesn't surprise me at all. So certification and a membership-based system. So the usual way this sort of thing is done, it's even done with USB. If you want to create a USB device, then and you want to put the USB logo on the box of your package, you have to pay the USB consortium to be a member, or whatever is involved to be able to do that. Otherwise, you're infringing on their trademark, because USB I think USB is a trademark of the USB consortium. So similar sort of thing. But it doesn't stop you from building devices that are compatible. And that's the important thing. Yeah, as Mark says, but the code is open, which is way better than other stuff. Exactly. Oh, Sion is here. Nice. Nice work on getting that Juki up and running too. For those of you who don't know, Unexpected Maker in the chat is Sion. Has just had a Juki pick and place machine commissioned in his factory and uploaded a video a couple of days ago showing the commissioning process. And yes, that is a very, very nice machine. Probably worth as much as a small house, but right. Okay. Where are we? Back to the chat. All right. I'm going to have a look in this box. And so Henrik said, the bigger one, can you open it correctly, please? Just don't cut it open. Okay, I will be careful. I will be very careful. If you open the bigger one correctly, you'll see a secret. I hope it's not broken in the package. I will be careful. Well, Keith said, use Lachlan's robot chainsaw to open it. No. Oh, Stephen pointed out only the original ESP32 has native Ethernet support. So that is why they've done the little daughter board. So in this particular case, there's the expansion header on here on the left-hand side of this dev board. And then this board plugs in on top and it uses the WIZnet chip to provide Ethernet. And where was I up to? Next video, more assembly, less chatting. Okay, let's have a look. So, should I be opening the small box first? I think that was what the comment was earlier. Yes. Peter said, Henrik said you should have two packages, open the smaller one first. So, what I have is this. We've got this box, which is the smaller one, and then I've blanked out addresses and stuff, so hopefully it's okay on the big one. But what I'm going to do is open the small one first. I'm just going to move all of this out of the way. The small box, the tape on it wasn't sealed when it arrived. It was inside a plastic bag that was like heat sealed or something. So I cut that off, and that's what all of the shipping label was on. So I cut that off. And now let's see what is in the little one. Get that out of the way, move that box somewhere. And where are we? Keith said, hoping to find chocolates from Estonia. I sure am. Oh, Mad Techie made it along as well. Okay. Oh, I think that wish has been fulfilled. Yes. Look at this. Oh, I'd be happy with just this. Kalev. Gerald says, Kalev, I haven't heard of it before. Jez Camp said, we could have a cat in it in various states. Yes, these are Schrodinger's chocolates. Jez, I haven't seen you in the chat for a long time either. So, okay. I am so tempted to eat one of these right now, but I don't really want to be eating on a live stream. Oh, do I? Don't I? No, no, I'm going to resist the urge. That's so hard. You don't want to be listening to me. They are filled with alcohol. Oh, awesome. So it's... I don't actually normally drink. Like, I don't like beer and stuff. I don't have anything against it. I just don't like it. So I just don't drink. But the taste of alcohol is quite nice. So I'm going to try this one. And that is not at all what I expected. It's how do I describe it? It's like a crispy egg wrapped in chocolate and filled with whatever that alcohol was. Oh. Okay, I'm going to have to be careful about eating these. And it is quite strong, particularly for someone who doesn't drink. That's like biting into that, it sort of explodes and it's a shock. Henrik, that is so good. Okay. Next thing, I'm going to, where am I looking? Okay, I'm going to do this very carefully. I'm not using the robot chainsaw. I have a knife, a scalpel. Keith says, save some for the next barbecue, please. We shall see about that. All right, so I'm going to do this one very carefully. I can slice down the edge of the box here without going into the contents at all. And down there. Henrik, thank you very much for sending me this mystery package. Now, what have I missed here? I've missed a little bit of the tape, maybe. Oh, no, it's glued as well. So it's taped and glued. Sorry, this is kind of hard to get under the...
I hope you can use it someday.
What?
Your channel is so awesome, and I always try to join your live streams if I'm awake.
Can you hear
I
that?
wanted to send a stuff a long time, but just now got around to do it. So let's explore the stuff I've sent and see what happens. Best wishes, John Oxer. I hope I like the stuff I've sent out, and I hope you can use it someday. Your channel is so
That's
awesome.
booby trapped. How on earth did this make it through like a customs inspection?
So let's explore the stuff.
This is freaky. Hang on, I'm gonna show people what's going on here. You can probably hear a voice.
Your channel is so awesome.
This is haunted box. Yes.
I just wanted to send a stuff.
Look at this. On the front
So let's explore
is a
the
micro
stuff.
switch. When I press it, the sound stops. But on the inside, I'm going to try to get this onto the camera. On the inside, if I tip it, hang on, I'm going to lift these out because the box itself is the amazing thing. Look at this. There is a battery in there and a little board with a micro SD card on it. There's the micro switch, which comes through the front of the box, and a transistor, which presumably controls power to this. There's a speaker. So when the box is opened, hang on, I've got to get that out of the way. If I let go of this micro switch, it starts talking to me.
I hope I like the stuff I've sent out, and I hope you can use it somewhere. Your channel is so awesome, and I always try to join your live streams if I'm awake. I just wanted to send a stuff a long time, but just now got around to do it. So let's explore the stuff I've sent and see what happens. Best wishes, John Oxer. I hope I like...
Henrik, that is so unexpected and cool. You know, I'm going to unplug the battery from that, and just so that it doesn't keep going when I put the box down. Oh, that is really, really cool. Oh, Henrik says it's a 5-volt regulator. Okay, yeah, because it's a 9-volt battery, and then it's supplying 5 volts to the other thing. Yeah, but Mitchell says, Henrik, well done, pretty slick. Oh, Hammer wants to know, where's the glitter and fart spray? Right. Yeah, where is the glitter and fart spray? Luckily, I'm not a Mark Rober victim. All right, so we have a couple more boxes here. These are very suspiciously packed. Like the way they're packed is like, I don't know, little treasure chests or something. But yeah, I can just imagine. Now think about what Henrik has just sent me. It's a box with electronics inside it, including a battery wired to a micro switch connected to the cover of the box. So if you open it, the micro switch is activated. Now, that is just screaming, suspicious package, destroy me. So if that had ended up going through like an X-ray machine or something, and the person had been paying attention, yeah, Mad Techie just said, how the hell does that get through customs? Exactly. It's like tempting them to to pull it out. Yeah. If anyone had noticed that on an X-ray, seriously, they would have destroyed the package. They wouldn't have even opened it. It would have been destroyed in a controlled explosion. Okay. These two boxes, one of them is kind of heavy, the other one not so much. So let's open this up and see what's going on. Okay. Now I don't know which way is the top of this or how it's meant to open. So it's got foam around it as a bit of extra padding, I guess. I don't know which is the top. Looks the same either way. Okay. Pop this. What? More food? Look at this. Catio Messy Cup. You're trying to put some weight on me, aren't you, Henrik? Let's see what else is in there. Oh, so many snacks. Oh, oh look at this. Varna Talon. So this is something from Talon in a mini bottle. Vodka. All the way from Talon. What are these ones like? Tilweke. I don't know. I'm going to open one just to see what it is. I've got no idea what sort of volley it is. Looks like chocolate, but it may not be. Oh, that's good. Okay. I'm going to put these back in the box. While I'm eating. I think lunch is sorted. Oh, so nice. Where can I put this? I'll just put it up towards the back. All right. Mark's Labs says take a shot. No, not yet. No. Okay. Let's see what's in this one. All right, so this box, everything has been food so far, apart from the box itself. So this one has tape on one side and just fold on the other. So I guess I open it from this side. Imogen said, did I just hear you say sugar coma? Yes. All right. What do we have in this one? Is this electronic stuff or is it more food? Looks like electronic stuff. Okay. What have we got? I can't even tell what that is. There's a lot of stuff in here. A lot of different bits and pieces. Ooh. That it's got some banana plugs on it. And that's a Rev 3 kit, oh, half kit PCB. All right, so it looks like I might be firing up the soldering iron anytime now. Okay, let's, yeah, there's a lot. There are a lot of, this is, like it's a reasonably small box. You can see just from my hands that it's not that big, but there are a lot of things in here. This is really interesting. Okay, this has got my attention because of the banana plugs. And Peter says, try eating the electronics. Got to taste test all the stuff. Henrik says, the PCBs is my made and the components not. Okay, so these are PCBs that you did. All right, I'm going to open this one up. Yeah, it looks like it's heat sealed and I can't see any other way to open it. So I'm just going to cut this. Just judging by how many things there are in this bag, this might be more than a live stream's worth of stuff. Okay. What is going on with this? All right, Henrik. I'm going to keep opening it and keep investigating. But if you feel like dropping an explanation, the banana plug PCBs are made for school, says Henrik. I vacuum and heat sealed, yeah. It's a very good packing job. Nearly got it all out. A lot of different PCBs. Okay. What I'm going to need is some little boxes to put each of these things in so that they stay kind of organized. Otherwise I'm going to end up with so much stuff on my bench here. Alright, so what we've got are different boards with banana plugs on them. So that looks like a transistor perhaps. What is this one? Where's the part number on it? It's printed around the side. TFK, 2K. I have a bit of trouble reading that one. There is a variable resistor. So I'll just arrange these in a way that you can see them on that camera. And then we can have a look at what we've got. Okay, so some bare PCBs there. More bare PCBs. This one is a light dependent resistor. And that one is a board that is unpopulated. It looks like it's the same as this one, but unpopulated. And this one is unpopulated. Looks like it's meant to have perhaps 3 variable resistors. I'm not sure. And so, yeah, I'll just lay them out and then we'll work them all out. And that one's got a resistor on it. It's a 1 ohm resistor. That one's got a diode on it. Okay, so just based on what I can see here, it looks like these are all designed to plug into like a carrier board of some kind. So, okay, so Henrik says, in school they have Festo learning board and they are made for those. Right. Yeah, so a Festo learning board, I haven't seen those before. I'm going to do a quick search for that. But my guess is it's like a giant sized breadboard. Festo AU. Yes, is that... no, that's probably not the same thing. I don't know. It's not diode, it's PTC. Oh, okay. The yellow one needs 4 switches. Right. Yeah, okay, so it'll be like a large carrier board that you plug modules into and then you can interconnect them, is my guess, using these banana plugs. So there's these are all different devices. So what I would need to do is get more of these plugs and solder them onto these so they can be plugged into the carrier board. And of course I need a carrier board. What is that one for? Looks like there's a part that's meant to go on there. Oh yeah, so this one is for 4 switches. This one is for a single switch. This one is for more LDRs, so that's a populated LDR. And these are bare ones that could have parts soldered onto them. Interesting. Okay, so Henrik, do you use Festo? Search Festo Electronics Kit. Okay, I will search for that. Festo Electronics Kit. Oh yeah, there we go. I will pull this up on the screen in just a second. Universal patching kit on a 19mm grid, and we want that. Alright, now can I get this, make this picture bigger? Yeah, so it's like a giant sized breadboard. Looks like there's probably a power supply, and then you can jump across. So what you could do is use cables, basically cables with banana plugs on the ends, and you could make point-to-point connections like an old style telephone switchboard, linking different things together, and then plug the modules in and join the modules together with jumper cables. Festo.com says Austin's Creations. Okay, so that is what all of those modules plug into. Groovy. Oh, Henrik says, and these are the things that are not supported, so I created those. The nice thing about this sort of system is that it is extensible. If you want to make a module that fits into it, then all you have to do is match the mechanical outline and come up with your own things, which is what Henrik has done. That is really, really cool. Nice. Now, I don't know if there is any more Festo related stuff in the box. So I think what I'm going to do is I'm going to keep that in, like, keep it enclosed. What am I going to use? I need something to put it into. I should have like a takeaway container or something somewhere. I normally have a big pile of them ready to put things into. Yes, over here I have. I buy packs of takeaway containers so that I can then have them ready whenever I want to store stuff away. So I'll put all of the Festo, related things in here. That's really cool, Henrik. So one thing I'm interested in is the process of you doing this. Was this part of a school project, or was it just something that you did because you wanted to do it as an extra activity, your own initiative? Or did other people in the class also think, also want to do that sort of thing? Now, what do we have here? Oh, a video ballon. Okay. Whoop. That is an unusual thing. And I don't think this... Yeah, well, that goes into there. But what is the purpose of this? Is it just a curious thing, or does this relate to something else, Henrik? Oh, Henrik says, it was only my idea with my money. So you went to, yeah, you went to the trouble of designing them, and yeah, and having them made yourself. That is really cool. In all sorts of different colors too, just to make it interesting. All right, so Henrik said it's for CCTV over UTP. Oh, okay. So you could plug in a, come on. Now I can't get this off. It's unscrewing. Or is it? Nope. Oh, there we go. Oh, okay. I was turning the wrong thing. Right, so you could connect twisted pair cable into there and pass the video signal through from there. Ah. And I presume that this comes out of an existing camera. Like this part here would have been inside an analog camera. And I can see that there are some little crimps on the cable here. It's been in like a cable retention mechanism, like clamped into an enclosure or something. And there's another one there with the lead hanging out, would be my guess. So this would have been inside an enclosure of some kind, plugged in, and then this would have been the lead coming out of it, which can then go into the ballon. All right. I don't know if there's anything much else we can do with that right here on the stream. Stephen says black cable plugs into the camera, then grey bell into UTP. Right. Now let's have a look at this one. This might be the point at which I need to warm up the soldering iron. Let's see what's in this. This is all so well packaged, Henrik. I like all of the vacuum sealed bags. Alright, so Rev 3.0 PCB half kit. Alright. Rev 1.0 PCB with errors. Rev 2.0 PCB with errors. And my guess is that this is a Rev 3 PCB, probably without the errors. Does it have a version on the board somewhere? Not that I can see. Dave mailbag, made by Henrik. Okay, what does a Dave mailbag do? Oh, Mitchell says in CCTV analog, usually you'd use power axe, which is coax and power single cable, but it's thick. So guys will send a UTP cable and use ballons instead, or for 2 cameras on single cable instead, lower cost. Right. Yeah. Oh, Stephen W asked EUV blog. Well, that was going to be one of my questions as well. So on here it says Dave mailbag. Was this made for Dave Jones's mailbag? Might have been. Alright, we've got a whole lot of stuff on here. Now, Henrik, should I assemble this? Is the question. What is the plan for this particular thing? And let's see what else we've got here. Oh, we've got a BM1750. What is a BM1750? Well, it says GY302. It's an I2C device. Maybe, I don't know. Could be an accelerometer or something, some kind of sensor. The GY makes me think of gyroscope. And this is, it looks like an environmental sensor. That is a BME 280. Yes, it is. BME 280s, they do temperature sensor, temperature, humidity, and atmospheric pressure, which is also an I2C device. And then this one is AHT10. That's a temperature sensor module. Once again, I2C. So we've got a few parts we can put on the board here. Where is Henrik? Okay. It was firstly meant to send to Dave Jones. Okay, cool. Mega shield. Oh, no humidity. Okay. Well, shall I do some soldering and put this on? Put these parts on? Or should we continue with opening things? I can assemble this one on the stream right now if you like. Mega shield. Okay, so what's it got? Parameter, lux sensor, gas sensor, AHT10, and OLED. Okay. And then it's got multiple connections, micro. So there's a micro USB connector there, mini USB there, and some other type of USB connector there. So we've got 3, oh, it's USB-C. So it's got 3 different USB connectors on it, and presumably an OLED. Well, it says OLED. And this, it looks a lot like an ESP01. Is this an ESP01? Which is a ESP8266 based module. Looks like the Espressif logo. It's a bit hard to see because of the printing on it. But does that go on here as well, or is that unrelated? Oh, it looks like it goes on there. The text is upside down. Maybe it goes there. Maybe it goes underneath on this side, perhaps. Okay, Henrik says assemble the USB kit first. All right, I will do that. So everybody cover your voice assistant's ears, because I'm going to say, Alexa, turn on bench 1. And on. Need some more light. Which tip do I have in the soldering iron? Yep, got the K-tip loaded, that'll do. So what resistors do we need to put in here? Where is my little 3D printed resistor bender? All right, so it's going to be on the second one. What's the length of these resistors? Yep, on the second one. It looks like we've got two 10K resistors, a 2K resistor, and a 1K resistor. And what is this one? This is red, black, red. I gave up on reading resistor color codes a long time ago. Basically because like once resistors went to metal film 1%, you can't read the colors on the blue anyway. So, red is 2, black is 0. So that is 2, 0, and then there's another red which is 2, so that is another 2 zeros, which means this is a 2K resistor, I believe. And this is probably the 1K resistor. Looks like brown, black, black, brown, brown. So that is 1K in metal film 1%. Let's put on the 10K resistors first. Just use my handy dandy little bending tool to make sure the leads are nicely bent. So 10K and 10K in there. I'm going to have to try to pay attention to the chat while doing this, which is not going to be that easy. Okay, so this one, that one is the 2K resistor. Red, black, red. Somebody please tell me if I'm reading that incorrectly. I'm just doing this from memory, and I may not be interpreting that resistor color code properly, but I'm pretty sure red, black, red is 5% 2K. Look, the arrows, yep. All right, so Henrik's comment about looking at the arrows, that's in relation to the position, I think, of this, like where that goes on. But we'll get to that in a moment. Let's solder some other stuff on first. I'll put on the 1K resistor, which goes there. Need some of the handy dandy leaded solder. Let the soldering iron heat up. I like assembling kits. Everybody else, while I am being boring and not able to really pay much attention to the chat, what things have you been up to for your respective weekends? And maybe a more specific question and more tuned to this topic is, what projects have you been building? Now these are going to be the interesting things, the USB connectors. I could do this. This one looks like a power only USB-C connection. Now I could do this with hot air, or I could do it with a soldering iron. I think I might do it with a soldering iron. This is, I had one of those little mini hot plates. That'd be perfect. Yes, I need to order one. So Henrik, the question is, what is the reason for having 3 different USB connectors on here? Is this simply wired in parallel so that you can use whichever cable most suits you? come on, can't get it in there. That's it. Do they all do the same thing? That would be my guess, but I could be wrong. Now, is the microscope working at the moment? The microscope camera, I mean, it's kind of working. Now, which one am I going to do first? I will switch to the microscope camera in a second. Right there and there. Yeah, this one I'm just going to have. It's got some pads under it for some anti-rip-off pads. But I've got to turn down the brightness because it looks too bright on the camera. I'm going to need to take some more medication before too long. All right, what I'm going to do is just mechanically attach it by putting some solder into the first hole and reflow it and let it sit down in place. All you can see was my big finger there, and now you've got some of my fingerprints. And solder the other side. I want to get it mechanically nicely mounted before I do the electrical connections, so that there's no strain on those electrical connections. Okay, there you can see the pins. It's a little bit out of focus because I've got it angled up. Let's fix that focus. Should be about there somewhere. I need something to lean this against. I'm going to move the microscope away a bit. Put this in place. I'll see if I can prop this somewhere. This is kind of awkward. All right. Yep, that's it. Oh, I should solder these back stakes as well, just for mechanical stability. Don't know if anyone can actually see what I'm doing. There we go. So the micro USB socket is on, it's all soldered at the back. The mounting stakes are soldered, so mechanically that should be very strong now. All right. Intermission time while I take a quick look at the chat. Picture in picture is in the way, not showing anything useful. That is true. All right, I will turn that off in just a second. Did the stream die? I don't think so. I think we're okay, Henrik. Dreaded buffering of doom stuck briefly. Okay, so Peter says, my weekend has been filled with the wonderful world of RTSP hacking. Fun. Austin says 3D printing. Stephen said to Peter, needs more OnVIF. Philip says, I'm currently working on designing a resistance soldering unit. Oh, I would like to learn more about that project. And also, Philip says, using an ATX PC power supply and using an IBT2 H-bridge to switch the current, also using an ESP32. Right, nice. And okay, so Henrik, in response to my question about having the 3 USB connections, Henrik said that it is just to work with whatever cable you have. Okay, I'm going to kill, which means I can now use a tissue, and you can't see me doing it. Because my nose is starting to run a bit. Now, USB-C. All right, let's get this to a place where you can usefully see what's going on. So here is the USB-C connector. And you can see, interesting. Does that footprint match? That it does. Unless it's a very odd footprint that happens to, no, I don't think it matches. I was wondering if it did something fancy, like, you see how I've got it aligned there, and it has doubled up pins, so each pair of pins goes onto one pad, but it doesn't quite align with that. So, oh, the position of the mechanical pins doesn't quite match. This connector has, oh no, it doesn't have any other locating stubs. It's just here. Come on, I've got to get this under the camera. Where is it? Where is it? Got to find it. There. I need to zoom the microscope out. Yeah, it's not quite sitting down flush to the PCB. It's sitting, I'm going to move this way up so that I can get the view on an angle and in focus, and you'll be able to see what I mean. There. You can see that the back is not sitting down when the front stakes are in, and the back stakes don't quite go in. I don't want to force it, but it looks like the only connections that come off this on the PCB are the power tracks. So you can see this one here on USB-C connections, the outer one's usually ground, so that'll be ground and that'll be ground, and then these two will be power coming in. And it looks like there's no data connection on there. So it's, yeah, normally on this USB-C connection, I think, I'll move it off there so we can see it better. Normally it would be ground there, power there, and then ground there, power there. And then these others are things like the CC lines, the data lines, etc. Yeah, so normally with this 16 pin, this is a 16 pin USB-C connector. So it would be data plus and data minus, and there are two of those, so that accounts for 4 of the pins. And then there is CC1 and CC2, which are the charge mode signaling pins, or the you know, the power mode signaling pins, which are the things that you stick a resistor on to show what power you want. Okay. Oh, other. Oh, Stephen says that's a power only footprint, but not a power only connector. Yep. Oh, Henrik said it works for me. Okay, cool. Well, that's very good. So other projects. Emmy said I'm doing some paint making. Hang on, paint making? Are you actually making paint? That's what it sounds like. As in, how do you make paint? And yes, I know that sounds silly coming from me, because I thought of actually making paint myself at home. Oh, Gerald says, I'm playing with a stepper motor controlled by a rotary encoder on an RPi Pico using MicroPython, just for fun and coding practice. Nice. Dave Paul Jones has been adding an MQTT broker to UPAS and changing a license to GPL. Yeah, I'm getting buffering. Been making my robot, yes. So that is something for a future stream. So I have seen I've seen some info about that robot, and it looks pretty awesome. Now, back to our scheduled program. I'm going to leave off that USB-C connector and have a look at this one instead. In fact, I'm going to zoom this out a bit, because it was a bit too zoomed in and making it hard to see what's going on. All right. Now, I don't actually need to put all these USB connectors on, but I'm going to do it just for the fun of it. Okay. I'm just pushing this connector onto the board. Takes a bit of force to push it on. Okay, so that is now sitting in place. And same as before, I'm going to solder the mechanical pins first. What can I use to angle it? I'll just prop it like that. Then you can slightly see down the side. I'll fix that focus. Okay. So I don't actually need these other USB connectors. I'm just soldering this one for the fun of it, because soldering is fun. Yeah, you can see the Kapton tape over the back of the connector, And the reason that is there is to provide a flat surface so that this connector can be picked up in a pick and place machine and shoved into a board. Now I'll do the other side of the connector, which is going to require some focus because it's quite elevated now, sitting up on the side of my cutters. So mechanical mounts first. And then we will do the pins on the back. How is that focus for you? Just got to check the focus on the camera as opposed to the eyepiece. Okay, I think it's about there. So let's... I've just brushed my soldering iron against something and melted something. I don't know what it was. But there is a little bit of black plastic now stuck to the tip of my soldering iron. Oh, I think I might have, because I wasn't watching what I was doing, I think I've just melted part of my soldering iron stand. Alright, now a little bit of solder wick to clean out between those pins, and we should be good. It's all done. We've got the 5 connections in there. Alright, what else are we going to put on this board? We could put on... We've got a reset button that needs to go on here. And then there is also another much larger button. Now, I haven't even stopped to ask. Henrik, what is the particular purpose of this board? I can see that it's got a whole bunch of sensors and things on it. And the ESP01 module. That's what I assume this is. It's got an ESP8266 on it and the flash memory chip, so that looks like an ESP01. So my guess is that this PCB provides a bunch of sensors, an input button, and Wi-Fi connectivity for an Arduino Mega. Bend that pin out. Pop that in. Alright, I'll solder on this push button. And was this something that was done as part of a school project or just something that you wanted to do for your own purposes? Because Henrik, you're showing a lot of initiative with this stuff. I've got to say, I'm impressed. Now, where are we? I'm just I'm just coming back across to the chat, trying to catch up. Oh, Dentistry said you can show the picture if you want. Yeah, that's the robot picture. I don't think we'll get to that today, but we will. Yeah, we need to get you on the live stream, and then we can talk about your robot. That can be for a future thing. Oh, so Himi, talking about making paint. Yes, from first principles. Got my mica pigment powder, gum arabic, honey and clove oil, mix it all together and then mold for a long while to combine the pigment and bind it properly. This is watercolor paint. Nice. Making your own paint. That's a pretty cool skill. Then there's a whole bunch of stuff about cameras and OnVIF. And oh, Dentistry said, did you solder all 5? May have been me, but I thought you missed the first. I will check that on the microscope in just a second. Okay, so Henrik's explanation. It's an inside thermometer with a CO2 and uploads things into ThingSpeak. Right. All the stuff I've sent you is just I wanted to create them. Cool. Yeah, oh, and Henrik says just the CO2 sensor was expensive. Yeah, they are. CO2 sensors are expensive. They're the ones with a little heater inside them. Gas sensor. So gas sensor goes there. All right, now let's check that pin. So there was that question about whether I soldered the first one. Yes, all 5 are soldered. It's a little bit hard to see on camera. It's much easier to tell with a proper 3D view. But all 5 pins there are soldered. And if I switch over to the micro, all 5 pins there are soldered. Yep. Okay, I'm going to leave the USB-C one off because I can't get it to fit properly in the socket. So let's put on some modules. What have we got here? This module is this is AHT10, and you can see the little logo on there shows that it is a temperature sensor module. So this is an I2C module, and the I2C address is 0x38 if that side is breached, and 39 and 38 if this side is breached. So you can change the address. All right, so AHT10 goes on the board where? Parameter. It just says parameter. Parameter. Oh, barometer, maybe? Is that what that one means? I'm going to open up these other sensors to go in the board. So this one is another I2C device, BH1750. I haven't heard of this one before. What is this sensor? My guess, as I said earlier from GY, was gyroscope, but that doesn't really make sense. BH1750. Let's look it up. Stephen asked, where's the 5 amp read relay? We will get to that. I'm sure we'll get to that. Now, what am I looking for? BH1750. I'm going to just pull this up. BH. Light sensor. Ah. It's a light sensor. That's not what I expected. Okay. Well, this is a different breakout board. This one is from DF Robot. But it says it's a light intensity sensor breakout board with a 16-bit AD built in. And there was a strange color on the top of that sensor. And that must be like a little photosensitive area. Right. Let's go back to having a look at that, because that is kind of curious. I'll get rid of that. BH. Yes, that is very curious. It looks like printing on the top of the chip. Now, if I get it at the right angle, you see how there's a little yellow square area on the top of that chip. When I first saw this, I thought that was just like ink. You know how components have part numbers and things printed on them? It just looked like a little bit of ink. But that must actually be a photosensitive area on the top part of it. Right. Okay, where does that one go? Lux sensor. Here on the board it says Lux sensor. So my guess is it goes that way on the top of the board. Is that right, Henrik? I'm going to zoom out even more. Really unmagnify the magnifier. Move this up and turn down the brightness. Brightness down. Yeah, about there. Okay. Lux sensor there. Is that correct? Yes. Yes, the arrow points that way. Very good. And Henrik has also provided a little bag full of headers here. So I will pop that open. And it looks like they've already been chopped to length, or some of them have. Oh, these are the headers for going onto the Mega. So this is the header for going into here. All right, what I will do is just tack this in place first on the main PCB. And push it into place. Okay. I'll solder the rest of them now that it's sitting flush. Now I can predict that I am not going to get to the point of actually putting this on a Mega and running it. Oh, that seemed unnecessarily loud. Lux sensor goes that way because that's the way the arrow tells me to put it. Yeah, just getting some of these parts soldered on is going to be enough for today because I want to get onto other things in this package as well. There is a lot of stuff still in the little box that I don't know about. Oh yes, there is the 5 amp read relay, which was teased previously. I am very curious to see that, to see how it works. So now we've got the Lux sensor on there. Now this one, is this, so the AHT10, what is an AHT10? As I said, I'm guessing that it will be a temperature sensor, but it may be more than that. Temperature and humidity sensor. Yep, okay. Oh yeah, Henrik says all these headers are PCB, yes. It goes down right corner, and I can send some codes for next weekend. Yep, cool. So right corner, AHT10. It even says it right there. I just hadn't seen it. All right. Well, I'm going to grab a header for that. AHT10. Oh, it fell out. Where's my blue tack? Where is my blue tack? My son probably grabbed it while he was doing some assembly, or I used it and not put it back or something. Hang on. Why did I only do 3? Did I just break that? I don't know. I don't know. I thought I cut off a 4-pin header. There we go. I am tempted to grab another one of those chocolates, the Kalevs. I've never had those before, and they are really nice. I want to go back to Estonia. It's a cool place to visit. Alright, I am going to do it. I had one of the vanilla ones last time. This time I am going to... Well, which one did I have? Yeah, I had the vanilla one, so this time I'm going to have one of these. Let's see what this is like. It is like taking a little shot of vodka. A shot of vodka wrapped in chocolate. And slightly crunchy biscuit. Mm-mm. All right. So gas sensor we don't have. Pyrometer. I don't think we have that either. So, or do we? No, I've got this. This got pushed away underneath other things and I didn't even realize I had it. This is the BME 280. Is it? Yes, it is. BME BMP 280. So this one is the barometric pressure sensor. So that one, I guess, goes there where it says pyrometer. Now I need another 4-pin header. Once I've put this on, I think I'm going to stop on this board and move on to other things in the box. Where is it? Yeah. Because I'm not going to get this up and running today anyway. And I want to get through some more of the things that are in the box. All right, module on. I didn't hold it for quite long enough. Got to let the solder solidify. Okay, so there we have, hang on, I'm going to go back to the overhead camera view and then, okay, so gas sensor that way, it looks, so Henrik, I just want to clarify, the ESP01 goes on the bottom of the PCB, is that correct? So it would go on there and the gas sensor would go on the top because there is an arrow here on the gas sensor on the top of the board and there is an arrow on the bottom for the the text is mirrored. I can't actually read it because the text is mirrored. So I think that goes on there. However, what I would need to do is put the gas sensor on first because I need to solder it on the bottom of the PCB and then cut the pins off. And then this fits over that solder joint. So the solder joints would be directly underneath this module and I wouldn't be able to do them after putting the module on. All right, and then an OLED goes on there. Okie dokie. I think I'm going to leave this one at this stage of assembly, unless there are strong sensor part upwards. Wrong way. Did I put the other one on the wrong way? I don't know. No, looks okay. But you can add the pins. Yes, I can. That's true. So what I could do is put the pins on first and cut them off on the bottom of the PCB. Then put the ESP01 module yeah, Imogen Ann says, this week on Superhouse TV, ASMR, Jono tried alcoholic Estonian chocolates. Oh, Henrik says BMP upside down. Right. Okay, so I should have put this over the other way. So it's pointing in the right direction that way, but it should be that way up. Cool. All right, let's fix that. Because fixing things is actually more interesting than doing it correct the first way sometimes. So, let's see. Situation where we have a module that is upside down, it's soldered onto its pin headers, and we want to take it off and clean it up and put it back the correct way around. Alright, so since I happen to have these little off-cut leads here, so these are leads that were off-cut from the resistors, I'm just going to bend one around. I mean, I don't actually need to do this for this because it's such a small thing. I could easily get this off without needing to do this. But what I'm going to do, just for the sake of the demonstration, is just put... where's a pair of tweezers? There we go. I am just going to put this... Ah! Stop it! Can't pick it up. It's being difficult. I normally use something like a bit of braided wire for this, but for this little demonstration, because it happened to be sitting on the bench, I'm just going to grab the resistor lead, the offcut, and then actually what I'm going to do for this is I'm going to drop that soldering iron tip, and I'm going to go for this one, massive soldering iron tip, just because it's got lots of thermal mass, and then I will dump a bunch of solder into it, like that, and then I should be able to just heat it all up and lift the module off. There we go, easy as that. And then I can just swipe that off, and now we've got the module removed from the pins. The pins are undamaged and they're pretty clean, nothing needs to be done to those. And then I will clean this up just with a little bit of solder wick. So with the same big tip on it, and just hit that, let the solder flow up the solder wick, and we should be good to go. Whoops. I just knocked a resistor off it. Is it attached to the solder wick? Yes, it is. Okay, oh, that's a capacitor. It probably doesn't even matter. That's a capacitor across the... Can you see it there? It's a little bit hard to see, but there's like an 0402 capacitor there attached to the solder wick. All right, I'm going to switch. What am I going to do? Yeah, I'll switch back to the other tip, the K tip, just to remove that cap from the solder wick. And there we go. There's the little capacitor. And then switch back to the mega tip, because I'm going to continue cleaning out the pads on here. Might do it from this side. Probably should have done it from this side in the first place. Would have been safer. Yeah, that's just V in and ground. I need to stick some flux on this. You know, at this point, it has clean V in. So at this point, I probably wouldn't even bother cleaning the pads out like this. I would just heat them as I'm putting them back onto the existing pin headers, and it would go straight on. Wouldn't be a problem. But just cause, let's see if we can get this cleaned out. No, it doesn't want to. Alright, so I might have to go for another plan, which is going to be very hard to show on... Oh, there we go. Yeah, so the pads are all cleaned out, and even though it doesn't really need it, switch tips again, back to the K tip. Let's put this 0402 capacitor back on the board. So, is it 0402? I think so. I don't think it's 0201. I'm having a lot of trouble guessing scale at the moment because this microscope is so zoomed out. My sense of proportion is all screwed up. Yeah, I think it's just an 0402. All right, so here we go. Now we can put it in again. So what you are saying, people, is that it should go this way. Is that correct? Still a little bit of solder impeding it there, but that's down in place. How's the focus? It's all right. Okay. Scott says, too drunk to operate tweezers. Henrik says, BMP still upside down. Yeah, sensor up. That is sensor up, but come on. Got to try to get it off again now. Okay. Sensor up. That is the sensor. That's it right there. Okay, so previously I had it on this way. And now I think it should be this way with the sensor up. Is that correct? I'm going to make absolutely sure before I solder this back on again. All good now. Okay, so Henrik says, all good now. But is that with this, with the sensor up? I think that's right. Okay, I am going to risk it all and solder it back on. Here we go. And if it turns out that I've screwed up a second time, well, I can always pull it back off again. Soldering is not permanent. Just solder, yes. Great. Alrighty, so what we have now is a partly assembled Arduino Mega Shield. Let's see if you can see it better on this view. And normally it would go that way. On an Arduino, you'd have the USB on this end and it would plug down into the PCB. So what we're missing is the headers that go down into the Arduino. That says LED. I wonder what goes there. Henrik, can you explain what goes onto this header down the bottom where it says LED and it's got a plus at this end? Is that to go out to an external LED strip, perhaps, or an RGB LED? I couldn't see anything else in the package, so I think I've already put on everything except the ESP01 and the USB-C connector. Hopefully I have. Ah, right. Yes, Henrik says WS2812B, for example. Sorry, I forgot the LED. Yeah, no worries. I've got plenty of them. Addressable LED with lead. Oh, I don't know if I've got any with the lead. Maybe? But it doesn't matter. Amy says, it's like me putting together an IKEA flat pack. I always put something on backwards or wrong. Yeah. Okay. Cool. So, I'm going to embagify these parts so that they all stay together. We've got the first two versions of the PCB in there. We've got the partly assembled one. ESP01 module will go in there. I'll put the USB-C connector in there. And then we've got the headers for the shield, which I haven't put on. But that's not a very interesting part. Is that everything? I think that is everything that was related to that kit. So I'm just going to do a little bit of a cleanup on the bench. I've got random little bags and lead offcuts and things. So I'll clear those out of the way before I pull out whatever is the next thing. Okay, so it's yeah, like a drinking game. I think the drinking game should be I eat a chocolate every time I pull something new out of Henrik's package. Which means it's time for me to, is it just the two types? Yes. It's time for me to have another vanilla. Vana Tallinn. Well, I don't know if it's vanilla, it just says Vana. What is it? No, maybe it's not vanilla. I was just reading it and reading it as if it was vanilla. I'm going to try biting this one in half to see what it's what the cross section is like. Let's see if I can do this without making a mess. Here you go. As you can see, it's like a crispy shell sugar lolly, which is hollow with the liqueur in the middle and then a coating of chocolate on the outside. So good. Next up. Oh, Henrik says, Old Tallinn. It's a liquor. It sure is. Okay. The next thing we have, what is the time? It's 11:30. How did that happen? What? Okay. I might have to open some of these on another live stream. All right. What we've got here is Arduino Nano AT Tiny Programmer. I'll remove the evidence. Gone. No one will ever know. All right, so we've got a couple of headers that would go on here. Is this your design as well, Henrik? Scott says, better be ready to take a taxi home after the stream. I kind of am home. I just about live here. I only ever go home to sleep, and then I just get up and come back here again. So what have we got? Capacitor. Okay. My guess is that these headers are where you plug in an Arduino Nano, and then this header is where you plug in an AT Tiny 85 for doing some programming. And then what is that part there? Maybe that's for an AT Tiny 85 as well, I'm not sure. Okay, I'm going to put the parts on this, and then somewhere around I've got a programmer as well. That and that. I need my solder again, and stick this back under here. Yeah, watching someone soldering is not the most thrilling thing in the world, but I like doing it. I forgot to speak for a moment. Okay. Now, what else do we need to put on? Okay, so what we've got is a cap. We have, oops, you can't see them. We have a cap, a couple of headers, a couple of switches, a couple of other headers that need to go on here. Now, this cap is going to need to lay down sideways. So long lead is positive, marked lead is negative. Bend it that way and lay it down flat so that the Arduino Nano can go on top of it. All right, I'll just solder that on. Yeah, a few years ago I did zero insertion force programmers for AT Tinies, a couple of different versions of it. I'll pull one of those out in a minute if I can find it easily enough. So then switches. Ah, okay, so what we could do is bend the switches over, I think. Is that the plan? Oh, and I'll put, no, I'll do switches first. All right, so Henrik. The second one is SMD AT-Tiny 85. Right, cool. Henrik says, yes, they're all my designs. Right, yeah, you've done quite a few PCBs. Then there is the mystery item as well you need to investigate. Yes. Okay, so what I'm going to do is bend the pins on these switches. Bend them over to be, oop, I slightly overbent. Bend them to be right angle. Bend this one to be right angle as well. Oh, excuse me. And then they can be soldered in like this so that they stick out sideways, because I think that would be a cool way to do it. Okay. Wait, stop jumping out. Stay in there. Mash it on with the blue tack. And I'll just solder one pin. Oh, come on, stop moving. Stop moving. Just so that I can then adjust the position. Blue tack off. Apply pressure. Reflow. Nice. And now it's sitting down. And then I'll do the other one the same way. Ah! It helps if I put down the soldering iron so I don't have my hands full of hot things. Just got to get the first lead on, and then I can adjust the position. All right, got to get them straight. Otherwise it's going to break my mind. Bend that a little bit that way, that one a little bit that way. Yeah, they look pretty straight. I need something to hold this PCB. It's just sort of floating around because it's got the other part sticking down. Okie dokie. So presumably these switches are for something like programming mode or power or something. I'm not sure. Maybe Henrik can explain. Okay, and these will be jumpers for, well, I don't know. I was going to make wild guesses, but I really shouldn't. I should, yes. My friend Andy told me off for this quite a few years ago. There was something I wanted to know, and I asked him about it, and in my question I posed what I thought was the answer. and he said, if you want to know the answer, just ask the question. Don't say what you think the answer is. And he's right. Come on. Because he was, if I just asked the question, he was ready to immediately tell me what the answer was. Because he knew. And instead he had to delay answering because he was listening to me tell him incorrectly what I thought the answer was. Okay. That's most of our programmer, apart from these headers for the AT-Tiny. I wonder, oh no, for the, not the AT-Tiny, that's what the programmer is for. For the Arduino Nano. I don't even know if I've got a Nano. I must have somewhere. Alright, let's try a bit of drag soldering on this. Let's see if I can drag solder my way all the way down this connector. Oop, I'm running out of solder. I should have peeled off a bigger bit of solder to start with. Okay, that's all the pins done. Other connector. The proper way to do this would be to actually have an AT Tiny and plug it in and solder it while it's plugged in, because then that would keep everything aligned. This is one of the many reasons that I like the K-tip. It's great for drag soldering like this. When you're doing headers, you can just go all the way down the header. Do it all in one go. All right, done. Henrik's AT Tiny programmer is assembled. Let's just take a... I'm not going to spend a lot of time looking if it doesn't immediately spring to my view, but I'm going to have a quick look. Can I see it from here? I'm looking for, so ISP, I'm just looking at boxes to see if I can spot the zero insertion force AT Tiny programmer that I designed a few years ago. It might be over here somewhere in one of these boxes. No. If it doesn't immediately spring out to me, I'm not going to spend time looking for it, because that would just waste time. We could be looking at Henrik's stuff. Okay. Programmer, I'm going to put this one with the box of the other parts. Now, okay. This time what I'm going to do is get a whole lot of things out rather than just taking them one at a time, because someone asked earlier, oh, it just keeps going. Look at this. How much stuff is there? Someone asked earlier about the 5 amp reed relay, and I am also curious about that. And what is that? It's a tiny little PCB with a blob on it. I don't know where that came from. It wasn't in a bag or anything. Okay. Yeah, there's a lot of stuff here. Got to make myself some more space. That is that connectors? I'm not sure. We'll get to that. Maybe. All right. So there's another board for assembly. Here's another board for assembly. Another board for assembly. This one looks cool. It's got a few, are they USB sockets? Looks like a whole lot of USB connectors in here and a big round PCB. This one's got my attention just because it's already, just because of the size and the weird dimensions. It's got some surface mount parts in there already. All right, I'll put that to the side. Here's another thing for assembly. Looks like this might have some surface mount parts in it. Yeah, this little module. I'm curious to know what that's from. Then these parts, can't really see what they are. I'll have to open them up. There's a, what is going on in there? Oh, this is a whole lot of surface mount assembly. Okay, cool. That's a different type of thing. What is this? More interesting parts. I'm going to have to look up what that is. So these have got 5 pins on them, and the part number is P3C49. I don't have a clue what that is. I've never seen that before. We'll get back to that. There is something here which is wrapped in foam inside the heat shrink, like inside the vacuum sealing. Here we have Neo lamp. Oh, this might be the 5 amp reed relay, perhaps. Okay, we'll stick that there. Here we have a globe. It's like a screw-based globe, and something else which I can't quite make out through the packaging. It's a silver cylinder. Looks, kind of like a big capacitor or something, but I'm not sure what it is. I really can't tell what that is. I've got no idea until I open it. Then we've got a couple of, looks like breakouts, RJ45 breakouts or something. And this one is possibly just a variable resistor. Can't really tell until I get it open, but my guess is that it's just like a potentiometer. Center pin, wiper, and then goes around the outside. Okay, so where to begin? All right, I think this is probably the thing to look at initially. This is I think this is the 5 amp read relay. Oh, Henrik says you can't use Google. It's the mystery items. There is another package as well. Another package? It's an AliExpress timer module. The resistor chooses the time. Oh. Right. Okay. So I think that's referring to this. Let's chuck this under the microscope. So this is a, where are my tweezers, just to make it easier to pick up. So this is a little module with like an epoxy covered chip on it. So this sort of thing, oh, it's only single sided. Look at this. This whole PCB has nothing on the back side at all. There are no tracks or anything. You can kind of see through, if we get the light at the right angle, you can see through under the black blob. So this is the sort of thing that's done when cost is being pushed down to the absolute minimum for large-scale mass production. The bare chip die will be bonded onto the PCB, and then like little bond wires go from the chip onto the PCB, and then a blob of epoxy or something is dropped on top of it to seal it and make it robust. So it's like it's a packageless IC put straight onto the PCB. And that is the super cheap way of doing things if you are making things in vast quantities. And it looks like there are spots here for some parts and a spot there for a part. So maybe that's what Henrik is talking about, where you can configure the timer. So this is a timer module. All right. Now, back to this. Let's have a look at what's in here. All right, I'm going to move these aside just to give myself a little bit of room to work. Let's see what this is. Okay, so neolamp. That I think will just be like an incandescent globe. Yep. All right. Now, why is my... Yep. Oh, timer data sheet next week. A small thing is the timer. Yep. Timer data sheet next week, says Henrik. All right, so we've got an incandescent globe here. What's the rating on it? Neo lamp, 3 something 100. What's the rating on it? 100 volts? It's a little bit hard to see. 3 watts, 100 volts is what it looks like. A bit hard to tell. Maybe it'll say it on here. Oh, 160? It's hard to tell if that says 100 volts or 160 volts. It's hard to tell both on the lamp and on the printing here because it's a little bit smudged. But this is the relay, and this is yeah. So when Henrik said that he was going to send me a 5 amp read relay, I was a little confused about that, because the way read relays work is is different to a normal relay. And I think technically this is not a reed relay, just looking at this, because it's got a coil and then separate contacts. So what we have are contacts here. Alright, so these two contacts on the bottom, I presume are connected to a coil in here. So there is a coil that goes around this core. So that's a metal core. When you apply power through that coil, it magnetizes the core. Well, it generates an electromagnetic field, which then attracts this. You can see that these two things move relative to each other. And when this moves, it'll be hinged down here. So it's mounted on this long arm is mounted on a hinge. Well, the hinge would be at the bottom. As it is attracted, so this part becomes magnetized. This then moves across, pulls sideways, and there's a little joiner piece here which is attached to this contact. So this contact would be fixed in position, and this one can move. So that moves with this. So when that pulls in, it pulls the contacts together and closes the circuit. So the circuit that is being switched is on these two contacts. Yeah, I wonder if technically this counts as a reed relay, because it has separate connections for the coil to the contacts being switched. And a reed relay normally is activated. Yeah, I suppose that is how a reed relay is activated. So what is the difference between a reed relay and a regular relay? I thought it was because... So this is like a... I kind of need to draw diagrams. So my understanding, I could be wrong about this, my understanding of a reed relay is that the electromagnetic field caused the contacts to close directly. And with a regular relay, the electromagnetic field moves an actuator. So we've got the armature and then the actuator pulled together, and that moves the contacts. So it's a secondary effect. You have the magnetic field working on this part of the relay, which then is mechanically coupled through to the contacts, and the contacts are what close the circuit. But the electromagnetic field from this coil in a reed relay, I'll turn it sideways maybe so we can get more of it on the screen. So the electromechanical field, the electromagnetic field from a regular relay is not affecting the contacts directly. It doesn't cause them to move together. What it does is move this actuator, which pulls the contacts together. So I don't know if technically this qualifies as being a reed relay or not. I don't know what the definition of a reed relay is. I'm just giving you what I thought it was. Okay, so. Okay. Henrik said it's just a regular relay. Reed relay is another vacuum sealed. Martin says just a different geometry, I think, a geometry difference. Reed contacts are a different principle. Yep. Yes. Henrik says, but look, the voltage on it, it's 170 volts. Should be another three things with a note. I can't see another three things unless they were in a... Where did they end up? No. Checking through the boxes and all the packaging. Nope. No, what I pulled out here is everything that was in the package that I can see. And I couldn't see a note. I wonder what's going on with that. Yeah, I can't see where the other things are. Maybe maybe in this. Maybe in this. Oh, you can't see. Wrong camera view. I want to know what's in this one, because I can't see it at all. So I'm going to cut this and pull it out carefully, because it's all wrapped like that. It's possibly something delicate. Where does this end? How do I get this out? Oh, there. Oh. Oh. Yes. Now look at this. I'll chuck this one under the microscope. This, I think, is what Henrik was talking about. So this is an enormous size reed switch, it looks like. Yeah. So with this, you bring a magnet near it, and then that causes the two parts of the reed switch to close. Now, do I have a magnet handy? I must have. Okay. Somewhere down here, I have a drawer labeled magnets. Where did it go? I've got to check the chat in a minute, see all the things I've been missing. But come on, where are the magnets? Oh, there they are. Okay. I found a magnet. So maybe we'll be able to see the mechanism move. Let's see. Can we? Oop. No, must need a stronger magnet than whatever this is, because the mechanism isn't moving. It's a very interesting construction. There's a lot of reflection that comes through on the camera, so you can't see it as clearly as I can, unfortunately. But you can see that there is a this bottom contact which passes through. Looks like it goes from here. It's the one with the little rubber thing on it. Passes through here, goes all the way through, and joins at this end, which also has a little rubber sock on it. So it looks like that's a continuous contact from this side. Comes in here, runs along the bottom, comes back out. And then this contact comes to a very thin arm. So this is the, I'll try to get it with the reflection off. Maybe if I turn down the brightness, you'll be able to see it better. Or if I get the angle a bit better. Yeah, there we go. Okay, so this contact comes through, and there's like a tiny little rivet inside there. And this contact is quite thick, but riveted on is a very thin bit of metal that comes along to here and is then riveted onto a larger chunk of metal and the end contact, which comes up to here. Now the way this is done, that is interesting. I'm going to have to draw a little diagram of this so that you can see it, because I don't think you'll be able to see it properly. There is a piece of wire that goes across, so it's like a horizontal contact, and it forms a little ridge, so that when the top part comes down, alright, I'm going to sit this right here. How can I put on it? I'll just put my cutters on it right here, and then I'm going to get myself out a piece of paper. Oh, I forgot. I've just opened something new, so I need to have another one of these chocolates. While I'm getting a bit of paper, I wonder how much alcohol is in these. Whether it is enough to actually affect me. Probably not. Okay. So, the structure, it's got the two contacts on the end, and then there's a little rivet. So this is all inside the enclosure, and there is a fairly thick piece of metal that goes along the bottom like that. Now, but the thing that is interesting, and the other contact comes out here with a little rivet, and it goes along to a contact. This is somewhat simplified, but this is approximately what's inside the enclosure. And this piece of metal is very thin so that it can bend down and make contact down here. Now, this is the thing that I just found interesting. Looking side on, there is a round piece of rod like this, which is bonded onto this bottom piece of metal. So if we looked at it in perspective, imagine, this is my terrible drawing. Imagine we are looking in perspective at this bottom piece here. This little rod is bonded across it like this. So it forms a ridge. It's like a speed bump. If you imagine you're looking at the side of this is like a cross section of a road with a speed bump in it. And this is like the road with the speed bump. That speed bump is formed by a little metal bar, which looks like it's been, I don't know what process, but like welded or something onto that bottom contact, so that it forms this shape sticking up from it, so that when this top contact comes down, it's not contacting flat, like a flat surface against a flat surface. It's the flat pad on the top contact moving down and contacting the top edge of this bar, which goes across. So now that I've explained all of that, if we switch back to the microscope view, and I'll point out those features that I was just describing, right there is just, you can just see it. That is the end. In fact, this warrants a zoom in, I think. Let's make this a bit easier to see. Yeah, you can see just there is the end of that little metal rod that runs across. So if I roll it all the way over, you can see the other end of the rod just there. So that's the little speed bump, which is mounted on that base contact, and then that top contact with that pad moves down and touches onto the top of it. And that would, the reason for that would be to improve the contact and reduce arcing and make it a more reliable sort of thing, rather than having two flat surfaces touching each other. It's a flat surface touching onto like a little ridge. Oh, you can just see it there. Interesting. So this must need a strong magnet in order to activate it. But as you can see, like looking at this entire structure, there is no coil in here at all. So yeah, this is what I was trying to describe before. I think what distinguishes a reed switch is that there is no coil. What it's doing is relying on a magnetic field coming near to it and causing the two contacts to be attracted to each other, just as a result of the magnetic field enveloping them. So on my diagram here, when an external magnetic field is applied, these two are attracted to each other, and this contact bends down and makes contact on here. Groovy. Martin says, what voltage and current is it rated for? Well, Henrik said that... Scott says, I thought Aussies got more coherent with more alcohol. Yeah, except that I'm not Aussie. I'm a POM. So let's check continuity. So where is it? Who was it that said? Yeah, Scott says check continuity of what you think is the continuous connector. I will, because it may not be. That is true. You're right, it is not a continuous connector. That is... so how does that work? What is... Oh, hang on. No, I just had bad... You can hear that? Yeah, I just had bad contact on the terminals. It is a continuous connector. Yep, but you are correct that I should have verified that and not just assumed. Peter says, you can tell he's upon me by his lack of bathing. Okay, Henrik said, can we open one sealed thing, the other one you can't see inside? Sorry, I don't understand. Which one do you want me to open? Oh, Philip said, probably constructed that way to stop the contacts welding together with high current. Yes, that's right. And as Henrik said, it's rated for 5 amps. Henrik said, Peter said, yeah, I'm not giving him stick for no lunch because he's been nomming all stream. I will give him stick for being a POM. Yeah, I have an Australian passport. Technically, I am Australian. I was born in London, but my whole life has been in Australia, pretty much. All right, so Henrik says, the other one you didn't see inside with the white thing. Ah, okay. This one, right. Yes. This is the other package, which is really intriguing. Yeah, we're already at 12 o'clock. But I do want to see this. What is this one? Another mystery package. Oh, there's a QR code. Look at that. That's a Superhouse QR code. All right, let's see what is going on with this. What these things are. What parts have 5 leads? This is a mystery. I thought I might have heard something move. Is this a type of relay? I don't know. It seemed to, when I tap it like that, I don't want to break it either. It just sounded like there was a contact or something tapping away. Like this is a type of relay as well, perhaps. Use the QR code, Luke. Henrik says use the QR code. Okay, I will use the QR code. Let's see what the QR code says. Hang on, I think I've got to get it out of the bag. I am really feeling quite congested, which you did not want to know. Okay. Can I read the QR code? Read it. Read it. Come on. Read it. I'll see if I can I can squash it flat. Oh look, a handy dandy 10mm spanner. I just need another one. I've got a packet of blades here. Let's see if I can read it now. Come on. Focus. It's got focus. All right, I'll see if I can find a specific QR code program. QR scanner. Let's see what this one does. Normally on the Android camera, yes, scan using the camera. Yes, allow. Oh, no thanks, go away. Usually using the okay, click, come on, scan. Oh, start here. Downloading here. Activate your account and access your unlimited multimedia contact. No, what is that? Is that just an ad? Ah, hang on, text. Ooh. Okay, there was something that came out of it. Secret, I can't read it. Click to search on the web. You can choose search engine in setting. Okay. Let's see. Can I do a translate? Google.com. Can I translate this? Scott said 10mm sockets are an ephemeral tool, single use, then they're gone. Yeah. Austin says 10mm spanner. Is that because you couldn't find the 10mm socket? Yes, exactly. I saw a very funny video, I don't know, a week or two ago, where there was a guy in a workshop, and he opened like a drawer of like a set of sockets, pulled out a 10mm, and it was like a first-person view, so it was what he was looking at. Pulled out a 10mm, put it down on the bench, turned to pick something up, turned back, and it was gone. And then it just like it kept escalating from there. So he then like got another one out and put it down, and then turned around and then turned back, and it was gone again. So what am I doing? Oh, okay. I am trying to translate. So Henrik, is this what is meant? Is this what I am meant to have seen? Oh, can't focus there. So I can't read it. I don't know what it says, but let's select all, copy, and I'm going to go to Google Translate and see what it says. Going to Chrome and paste that, search, and no, okay, I'm just going to go to Translate. Translate.google.com. And I will stick it up somewhere that you can see it in a minute. Oh, come on. Edit. Translate.google.com. Go. All right, enter text. Paste. Translating. Okay, so it is. So what this QR code actually says is, here is a secret component for you, and you must discover it using your knowledge of electronics. Good luck. Okay. So, I am not going to Google this part number. I need to figure out what this is. Now, yes. All right, so first thing I'm going to do, and unfortunately I really should have the multimeter set up on screen, shouldn't I? But first thing I'm going to do is put a multimeter into ohms range and try different contacts to see if I get anything across it. So that's open circuit. That's open. Those ones are open. 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 Okay, and open. Oh, hang on, no. It's 1.6 kilo ohms between those two pins. Now, what happens if I put the multimeter leads on the other way around? Because multimeters have a bias. Oops. 1.6 kilo ohms, 1.7k between those two pins. What about there and there? No, I think I've tried every combination of pins now. So I'm getting nothing except 1.6 to 1.7 kilo ohms between these two pins. So I'm hesitant to apply power of any kind to it because I don't want to damage it. But just for everybody's entertainment, let's chuck it under the microscope. So if anyone else is Googling or whatever for this part, please do not say what it is, because I want to see if I can figure it out without being told the answer and without searching for it. So you can see it's got 5 pins on the end. It's in a little metal can, which is all sealed apart from this end, and then it's got the 5 pins sticking out of it. Looks like it's been removed from something. Perhaps. It's a bit hard to tell, but no, it may be new. It could be just that these leads have been tinned to make soldering easier. So yeah, I think it might actually be a new part. It's not, don't think it's been removed and then cleaned up, although that is possible. None of the leads that I can see are connected to the case. So that was my next point of investigation. Is one of them, you know, like a 0 volt reference or something, or a shield? But it looks like none of them are connected to the case, at least visibly there. But I should check that. So what I'll do is measure resistance. There is some kind of coating on the case, but I'll measure resistance and then check each of these pins and just see if I can get any kind of conductivity through to the case. And I can't, so it looks like the enclosure is totally isolated from those pins. Okay, so that is a mystery. Yeah, power to the pins with resistance, says Scott. Yep. Oh, Henrik says they're actually brand new, just out of the box. Cool. Some call it fun, says flux capacitor, too many wires. David T says get out the Dremel. Cable tie says I can't believe we're still going. Well, with all of the stuff that Henrik has sent, I've barely got through half of it, if that. Yeah, Mike says guessing half the audience has looked it up now and knows what they are. Oh, okay, so Henrik says use power. Okay, all right. Let's... Peter said, nice stomach rumble there, mate. Yes, my stomach is complaining a lot. It might have to take advantage of that $10 donation towards the pizza fund that was sent through earlier. All right, apply power. Okay, so what I'm going to do is, what sort of power am I going to apply? Maybe, okay, where's a lead? A lead with a couple of jumpers. This one should, no, not that one. This one. Power supply lead with some alligator clips on the end of it. And I'm going to set it to VSET 5. I'll just give it 5 volts. And I'm going to set current limiting to 50 milliamps, just to be on the safe side, because I really don't know what this is going to do. Right. Peter says, use a random DC to find out what the current limit isn't. Keith said, apply power, maybe chocolate will ooze out. Yeah, Mike says, have a low current limit if you randomly connect DC. Yes. Peter suggested I put 240 volts across random pins. Okay. Now, I need to rediscover, back to here, I need to rediscover which pins they were. So, I think it was that one and that one. Yes. Those are the pins. So, what happens if I need some tape or something as some insulation. All right, a better way to do this would be with some jumpers, but what I need is jumpers that are like DuPont wires. Oh, that one will do. And that one will do. So what I'm looking for is just something that I can stick on there and that will remain insulated. But I need a little bit more to connect to. So it's that one and that one. Now, when I connect power to this, what is going to happen? All right. Is power on? No, it's not. All right, that is now connected and I've got it set to 5 volts, 50 milliamps. I'll just turn it on. Here we go. Let's see if the smoke comes out. And nothing happened. Alrighty. I wonder if 5 volts is enough to do anything useful. Now, while it is powered up, just in case it is some kind of a mysterious relay, I'm going to check across the other pins again. Nope, still open circuit there. That one there to there. Ooh, that's changed. Okay. So now we have close to 0 ohms across these other two terminals. But what I will also do is go to volts mode and stick that in there as a 0 volt reference. Come on. And then see if I'm getting voltage on any of these, which I'm not. Okay. So, when power is applied across these two pins, I'll chuck it back under the microscope. Oh. When and up. There, I'll take that back off. All right, when power is applied, at least when 5 volts is applied between that pin and that pin, then between this pin and this pin, the resistance drops to close to 0, or as close to 0 as I can measure it, which is interesting. But no voltage appears on any of the other pins. I'm starting to question whether that and that. No. Dunno. I am going to chew that one over in my brain for a while. Need smaller clips, yeah. Some call it fun said, let's hope it's not a blasting cap. Okay, Cable Tie says, did we get to see the markings on it? Yes, I'll show you the markings on it. Markings which I am not going to look up, but you are most welcome to. There. That's the thing. It's a 5-pin device. There are 5 pins in sort of offset grid pattern in a little metal can. And where are my calipers? Just there. It is about 10 millimeters wide, about 15 millimeters long, and about 5 millimeters thick. So if anybody wants to satisfy their curiosity and search for it, you can look it up, but I am going to resist the urge. Okay. Oh, Henrik said just use 12 volts. Just use 12 volts and then you'll hear it. Okay. Let's try that. I'm going to... Which camera do we want to use? I think we'll go back to the microscope, but zoom out. And I'm going to get these... Yeah, I was hesitant to use more voltage just because I don't know what this thing is doing and what I might break. All right, so we've got connections there. Ah, leads won't reach to the microscope. Oh well, going back to the overhead. Okay, so we've got the device here. And I'm going to turn my power supply up. VSET 12, go. Turn my power supply up. Ooh, I heard a click. It is I think it's a relay. Hang on, I'll bring this really close to the microphone so you can hear. You hear that? I think this is a type of relay. And someone suggested cutting it open with a Dremel. I am actually really tempted to do that. Not today though, because we're already past time. But yeah, I'm curious to see what goes on inside here. I think it's a relay. But what I'm confused about is why when I fired the relay, did I get a contact between these two outer pins? This pin doesn't seem to do anything. I would have thought that it would be like a single pole double throw relay, in which case one of these would be a common and then one would be normally open and one would be normally closed. But there's no contact through it, through what I think would be the normally closed pin. Yes, Keith said, why 5 pins? Yes. Haven't had enough chocolate yet. You're right. I have not had enough chocolate yet. But thanks to Henrik, I have a whole box of it. All right, it is now 12:25. My voice is failing. Yeah, Henrik says, yes, one is normally open and one is normally closed. Yeah, but I wasn't getting... Oh, Paul said to measure again. All right, I will measure again. But I was... Whoops, not that. That. So looking at the bottom of it, the arrangement of the pins, if I move this over here, is like... So what it looks like is that these 2 pins are the coil pins. So, and then what's happening is when it's powered up, I'm not even sure which one it was now. I think I've just picked up a different one. If I do... So that's the bottom center pin, which is this one that I've just plugged in. And then the top left pin, which is that one, which I've just plugged in. Now, if I measure between these 2 bottom pins now, I'll get nothing. In fact, what I'll do is I'll put it into continuity mode with a beeper so that you can hear it. All right, so if I measure across these two now, oh, what? It is making contact. And what if I measure across that one to that one? It's not. Okay, so I think that is common, that is normally closed, and that is normally open. But that could be common. So let's find out. We'll fire the relay. Ka-chink. And now let's see. Awkward. That is still closed. What about to there? Oops. No, that's open. And that's closed. Oh, is it? This is awkward. I need a, where's my blue tack again? There we go. Stick it back down into there. From there to there. Okay, those are closed right now. Those are open. So that is common. That is common. That's normally open. And that one is normally closed. So at the moment we go from the bottom left to the top right. And it's closed. And if I turn off power, this one will be closed. And that one will be open. Okay. So we've got the pinout figured out. So it looks like it's a 12-volt relay. Cool. In a like a very vertical format package, which could be really useful in some situations. Okay. All right. I'm going to go because I'm feeling quite under the weather and struggling through. I'll be okay. It's just hard work doing a live stream when I'm feeling like this. So, yes, as David says, slick little relays. Yeah. Well, there are more things here of Henrik's that I want to look at. Like this. I'm not going to open any of this when I'm not on a stream. I'll only do it on a stream. That looks like a little surface mount assembly project. This, I don't know what this is, but it looks interesting. It's like it's a circle of USB connectors, but I don't know why. We'll have to investigate that. This one is a surface mount assembly job, and it looks like it spells something out, but I can't quite see what it is under all of the packaging. My guess is that that is a whole bunch of LEDs, perhaps. So I need to put all of the LEDs onto the PCB. All right, that can be a future thing. And then there are these other things as well. There's other stuff that I haven't even opened yet. Some RJ45 breakouts. There are these things I haven't opened. And this, oh, it's a whole other shield with some connectors. All right, we'll get to that. And that, which is some more connectors. These things. Yes, there is more soldering in my future. Well, thank you, Henrik. Yeah, there is so much more. When I saw, when it got down to that last little box, I thought there can't really be that much in it, but there has been a lot. Yes, very cool. All right, check the DS. It's pretty. Mitchell says, now you have it. Check the DS. It's pretty slick. Pretty sick. What's the DS? I don't know what you mean about DS. Okay. Right. Well, my brain is flat, and so I am going to go. Henrik says, please next week as well. Oh, datasheet. Right. Yes. I will check the data. Okay, let's do that right now. What was that part number? The part number of the diode of the relay. Oh, there's a whole other pack. Is I know I was going to go P3C49. P3C49. Is that the part number? Electromechanical relay. Oh, it's 15 volt. Okay. Single pole double throw. PCB mount. What? Hang on. 500 megahertz? Does that even make sense? How on earth is an electro... What? Oh, I see. Max frequency. So that is the frequency through the contacts. Right, so it's an RF, as Martin pointed out, is an RF rated relay. Yeah. Okay. Oh, look, there's the little diagram. It even looks like mine, kind of. Just rotated 90 degrees. Yeah, Martin said PTT, which is push to talk for a radio transmitter, maybe. Yeah, okay. So it's an RF rated relay. With a 15 volt coil is interesting. That suggests that it is for some very specific use. David T says front end relay. Yeah. Cable tie says it doesn't switch that fast. Yes. No, yes. It switches 500 megahertz signals, but it doesn't switch at 500 megahertz. Yeah. That totally threw me for a moment. Cool. Right. Okay. I'm really going to go this time. Thank you, Henrik, for taking care of all of my snack needs for a little while and for sending me so many interesting things. And I will continue, maybe not the whole stream next week, but maybe what I'll do is do it over a little bit of time. Like next time I'll assemble one of the other boards and then another one can be held over for the next stream or something like that. We'll do a few. And also dentistry, the dentistry's robot. That's going to be something to talk about as well. Martin Visser said probably has some mercury wetting or something. Yeah, so mercury wetting on the contacts to allow it to pass that signal. Yeah. Awesome. Well, thank you very much for coming along and suffering through with me being a bit ill. And hopefully by next week I will be 100% and we can look at another one of these things from the package. So I am going to go and crash for a little bit and recharge my brain and then think about getting some lunch. So have a fantastic weekend. Thank you for coming along and I will talk to you soon. See ya.